So there exist two different ways in which we can write the nth root of a. So we know that given a real number, the nth root is written like this, right? But there actually exists an alternative notation for the nth root of a, and this is where we use something called a rational exponent. So this alternative notation states that a is a real number and n is a positive integer, then we can write the nth root of a as a to the 1 over n. So, for example, if I gave you 3 to the 1/2 power, 3 to the 1/2 power, this is the same thing as saying the square root of 3. But remember, if we're writing square root, we usually don't write the index 2 down. We only write the index if it's 3 or greater. So these two are equivalent notations. Or if, for example, I give you the cube root of 2, then you can rewrite that as 2 to the 1/3 power, right? So as it turns out, there's also an alternative notation for the nth root of am, of a to the m. So if a to the 1 over n is a real number, then a to the m over n can be written as the nth root of a to the m. You can see that it's true to have a little proof. Let me put this parenthetically. A to the m over n can be written as a to the m times 1 over n, right? I didn't do anything weird here. Which can be written as a to the m to the 1 over n power. And then if we use this notation on the top, then we know that it's the nth root of whatever's inside a to the m. Right, so we see that it's true. And to show you an example of how to apply this, if, for example, I give you a to the 2/3 power, you can rewrite that as the cube root of a squared. Or if you have 2x to the 5/3 power, you can rewrite that as, again, the cube root, since the 3 is in the bottom, of 2x to the 5th. Right? And in general, kind of make a note of this, if you have a to the m over n, you can think of it as a to the power over root. So that way you know that the denominator of the fraction is going to be the root number, and the numerator is going to be what power you're going to take it to. So that's in general how you can rewrite the nth root of any number in a different notation, particularly rational exponent notation.